Next part is how to test software. Now, software has become the most important part of any organizational workforce or a workflow. And you need to test your software regularly so that you see that your softwares are working securely. Okay. Just a small question, and then we will move ahead. Right. So it's pretty common sense, right? So what happens in code review is basically developers write the code and everyone sits together and reviews the code. Okay. So that is the main aim of finding bugs early, improving the quality of the code and knowledge sharing between different developers. Okay. Now, whenever code is being written, okay, there is a process by which you inspect the code. Okay. Now that process is called something called a code review process, and one of the most formal way of reviewing code is called Fagan Inspection. Okay, it's a formal code review process and generally carried out in very, very highly restricted environments. Okay, what is the flow? You plan for the code review, you overview what you need to do, you prepare, you inspect, you rework whatever the vulnerabilities were there, and then you follow up. Okay, that is called a Fagan inspection. Now, code review is a very, very common process in software development companies, wherein your teams, they sit down once a week. Once you have written a part of the code, it is flashed on the screen and everybody goes through the code, and the team lead keeps telling that these are the issues in the code. Okay, your peers also participate in that and tell you that these are the code issues to basically find very, very common bugs. But you can also test software utilizing multiple tools. Okay, you have automated tools for software testing like Sonar Cube. Okay, this is used for static code testing. Okay, so what you do as part of the DevSecOps process, which I'll explain in DevSecOps, you basically have your code, and then once the code is about to be, I'll say compiled, before that you have a tool which checks the code for common errors or common bugs. Okay, so you can use automated tools to carry out such automated code review at the developer's end only. Okay. Senior developers at times they do manual code review and sign off the code and then use automated tools to see that the code has been made in a proper manner. Now, good organizations who develop code follow this process. Now, the first part is how do you check the code? Now, what happens? Whenever you write code, if you have written, you write the code and now you can test it. It will give you line by line error. But if you compile the code, once you've compiled the code, then it will either become a binary or a executable, right? Binary if it is a library, and executable if it is a program. Now, if you want to test this software, right, then you have to use something called the dynamic tools. Dynamic testing tools. Dynamic testing tools are the tools which test the software during runtime. Okay, and static testing are the tools which test the tool when they are just a piece of line of code. Okay, so when say somebody use the word SAST, it's not some great shakes. It's just running a tool to see whether the code forms a very, very common good process of writing code. Okay, there are not unnecessarily loops. There are not input validations are not there. So such kind of issues can be brought out by static testing tools. Okay, but once you run the code, okay, you need a dynamic testing. Now the dynamic testing actually runs the code, and once the code is running, then it tests. So it finds out what are the vulnerabilities in the runtime. So it gives you runtime issues, runtime vulnerabilities. Now, dynamic tools will not have the access to the source code because it has been compiled. So since it's compiled, it is either in binary or it is in an executable form, right? Now in dynamic testing, generally user flows are tested. Synthetic transactions are done. These are very common questions in CISSP. What is a synthetic transaction? Synthetic transaction is basically say you are carrying out a money transfer, right? From account A to account B, NEFT transfer. So has the transaction happened properly? Dynamic testing tools can simulate these synthetic transactions for you. Okay. Now, in web applications, such things are done by a tool called Selenium. Selenium is a very common framework for testing web applications dynamically. Say you want to create a login process and see that everything goes fine 1,000 times. Okay. You can't do it 1,000 times and test login, right? So create a login sequence and tell the Selenium framework to test this login process again and again and again. And it can automatically do for you 1,000 times within hardly 10 seconds. Okay. So that gives you a operational perspective of a particular software. Okay. Then softwares are, since developers build softwares, there are a lot of errors. You can do fuzz testing. It's a very common testing for testing softwares to give it dumb data, to give you random data. If you do send random data and see, okay, as kids, we used to, give random data to the website and see how it is behaving. A lot of times software used to crash. Okay. So that randomization feed of data to a software is called fuzz testing. Basically, you are fuzzing the software. You're trying to give it plethora of data to see how it behaves. Okay. There's a tool for fuzz testing called XUF. Okay. XUF is a very common tool for fuzzing a software. This is the word from where fuzzing has come. Fuzzing means you are feeding data of, some kind of data to the software to see how it behaves. There are two kinds of fuzzing. One is mutational fuzzing and one is generational fuzzing. Mutational fuzzing is just dumb fuzzing. You selected a string of data and just fed it to see how it behaves. Generational fuzzing is intelligent fuzzing, where you are having data models to be fed to the software to see how your software behaves. Okay. There's a concept called bit flipping. Bit flipping is a very common way which hackers use to see how a software behaves. Bit flipping, what happens? See, bit flipping, what happens? You have a decision box and you check if this is yes, you do this. If no, you should do this. So hackers know that there are decision points in a software, right? And if you flip the bit, that is, if you put it, if it is 1, it is happening like this. If it is 0, something else will happen. They flip the bit in the software to check what is the next flow in the software. Okay. So before hackers do it, you do it at your own end to see a bit flipping and check how your software behaves. Then once you made the software, the next part is, software has different components, the login sequence, the application sequence, the hardware sequence. So you have multiple sequences, and now you want to check how it works once you interface the entire modules. Such kind of testing is called interface testing. Now, generally, you have 3 kinds of interfaces. You have the user interface, which the user is going to use. Okay. Then you have the application interface, where there are a lot of things which are there. There's database, there is application code. Okay. There might be, APIs, there might be hooks, multiple things, right? And these are generally controlled by API systems. Everybody has API these days. Okay. So you test that all the APIs are working properly. And finally, it has to be executed by some hardware. Okay. So how the UI, the application APIs, and the hardware works. Okay. That is checked in interface testing. Now, systems need to be tested for use cases and misuse cases. Now, what is a use case and what is a misuse case? Okay. If I put login name and password, it is a use case, right? Now, I might put by mistake some incorrect login. That becomes second use case, because this is a valid use case, right? Most of the times we forget the login sequence or we forget the password. These are use case. But in case I'm now this same use case becomes a misuse case when I put deliberately login sequence incorrect multiple times. First, second, third. Now this becomes a brute force attack. So basically, a same use case can become a misuse case. So you test software against there are a lot of known misuse cases against which you use a software. Now, suppose you built a application and there are 100 misuse cases or 1,000 misuse cases. You cannot check your system against all the misuse cases. Okay. If you are checking your system against all the misuse cases, then your software is very, very rugged, I would say. Okay. And that's why you have something called test coverage analysis. Okay. Say, suppose you had a total number of misuse cases as 1,000, but you don't have the capability to test your system for all these 1,000 misuse cases, right? So what you do, you say, okay, out of 1,000, or not all are applicable. What are applicable are only 250. So what you do, you have done basically 250 on 1,000. Okay. So basically 1/4, that is 25% is your test coverage analysis. Because in your risk management process, you saw that out of the entire misuse case, only 25% probably will be required. Okay. How do you test for such test coverage? You have multiple, I will say, analysis points. Okay. So codes are written in branches, codes have branches, codes have conditions, codes have function, codes have loops, codes have statements. Now, what all you want to check, that it becomes part of your test coverage analysis. Okay. Small question. Let's see how many of you remember a little bit of coding. Sumod covered the complete.
No, sir. This is something which I usually work on. I'm actually from the application security side, so that's why some of these things are common to me. I'm not from the networking side. I'm actually
Okay.
from the application security.
Okay, great. And this is the first time someone from application security is there in my batch. I've never had someone who was from application security.
Okay, sir. Glad to be in your team.
Okay, so Sumot says A, B, and C. Sumot, can you say why? And
because in a program you'll have a series of statements, then you'll have branchings, and branchings could be flows to other modules as well, whereas conditions could be very specifically check conditions, like if something is greater than another, if some those kind of things. So these are the typically ones that we use.
but the question is asking which measures the percentage of lines of code, right?
They have, because of based on the branch, right? You will have a different set of lines of code that would get executed for specific reasons, right? And same thing with the conditions also. So
say this is the
you have to
say this is the application, main application, right?
Yep.
And it will have branches, right?
Yep.
Okay, so this is one branch. Okay, this is second branch. This is third branch. This is fourth branch, right? Now,
so this would be like in terms of they were like, for example, you might have multiple releases for you might have an emergency fix. So that will become one part of your branch. For that branch, what is the coverage that you would test?
Yeah, suppose this is your complete application and this was the login sequence, right? And this is the branch for the login sequence, right? Now to test this branch, okay, you will have statements, right?
Yep.
You will have multiple statements.
Yes.
So where is the percentage of code will get reflected? Will it get reflected in the branch code analysis or statement code analysis?
You'll start with the statement code, sir.
Yeah,
start with the statement code.
So in this particular, it's a slightly technical question. Though your answer is technically correct. Technically, because here ultimately the statement will be covered under branch, and there will be conditions in the statement itself. But generally, when we say lines of code, we generally deal with statements, because each statement will have percentage of code inbuilt in that.
Got it, sir.
Answer for this.
Sure.